Hello, I'm Justine Murphy with Laser Focus World. Let's take a look at some of the amazing things happening in photonics. Imagine shrinking a huge optical system on a satellite in space to the size of a tissue box, while still maintaining strong data transmission and communications. Well, that's just what scientists have done. A team from Spire Global, a provider of space-based analytics, data, and logistics headquartered in Washington, D.C., has achieved two-way laser communication between two satellites in orbit. The satellites involve the world's smallest optical inter-satellite link payloads the team developed with support from the European Space Agency's Advanced Research in Telecommunications Services project. The payload technology now allows information to be sent between the satellites as far as 5,000 kilometers apart, nearly instantaneously via lasers. This level of performance has conventionally only been possible with very large optical systems. Spire earlier this month launched more low Earth multi-use receiver, or LEMUR satellites, equipped with this payload technology. The team says their triumph is poised to significantly enhance the security, speed, and efficiency of data transmission for uses like weather forecasting, remote sensing for navigation systems, and environmental monitoring. Lumentum has announced it will soon become a key player in the silicon photonics ecosystem at NVIDIA, a developer of technology used in gaming, computing, and AI. High-power, high-efficiency lasers developed by Lumentum, a California-based designer and manufacturer of optics and photonics for cloud, networking, and industrial applications, will aid the advancement and ultimate deployment of NVIDIA's Spectrum-X photonics networking switches. Company representatives say these systems should significantly reduce power consumption, enhance technology resilience, and enable faster implementation. Elsewhere in the business sector, hybrid organic electro-optics developer NLM Photonics has named Dr. Anthony Yu a strategic advisor as the company advances its technology. The former vice president of silicon photonics product management at semiconductor manufacturer Global Foundries, Dr. Yu will help NLM establish an ecosystem comprising foundries, optical chip designers, and others. Company representatives say a goal is to use their technology to ultimately implement and qualify optical modulators for AI data centers. Researchers led by a team at Mass General Brigham have developed a non-invasive approach to controlling cardiac activity, potentially revolutionizing heart repair and treatments. And all it takes is some ink, some printed tissue scaffolds, and a little bit of light. The new approach involves optoelectronically active ink integrated onto bioprinted tissue made of cells and other materials that are compatible with the human body. The ink is remotely stimulated by light, which in turn generates electrical activity in cardiac tissues and allows them to be manipulated. Existing 3D bioprinted tissues can only do this with wires and electrodes placed inside the body. In tests with preclinical models, the researchers also found their new ink-incorporated tissues can synchronize with heart rates and control them. They say this could make heart repairs and related treatment more effective and more successful. The new system lays the groundwork not only for non-invasive light stimulation inside the body, but also tissue regeneration and body integration capabilities for cardiac therapy and potentially other types of electrically active tissues. And that's your Photonics Hot List. Be sure to like and share, subscribe to our YouTube channel, follow us on social media, and visit laserfocusworld.com for the latest and coolest news and information. Check out our Following the Photons podcast, too, for some cool interviews and news impacting the industry. Until next time.